We will get started here. As you remember, if you were here on Tuesday, or um, as you'll figure out if you go back and watch my lecture on Tuesday, remember we were talking about building codes, and we were talking about the family of I codes, right? I codes are model building codes that are made by the International Code Council on 3-year cycles. So we have the IBC, the International Building Code, the IRC, the International Residential Code, the IECC, the International Energy Conservation Code. So we have this whole family of I codes. And recall that the concept was that individual jurisdictions, for the most part, don't have the ability, the wherewithal to write a building code, right? I live in Oak Park. The Village of Oak Park doesn't have the capability of writing a building code, but they can take a model building code and adopt it and use it for their own. So that's generally speaking the way that things work. So you see on the map here how building codes are used and adopted varies, on a state-by-state basis. So in the state of Illinois, building codes are administered at the local level. So there is not, you see, like some states like California, for instance, has a state building code. So if you happen to be working or building in California, you'd have the same building code irrespective of what town or city you're in. In the state of Illinois, that is all administered at the local level. So you're in all likelihood going to have the International Building Code in almost every town or city or village in Illinois, but they might be adopting different versions of it. Again, remember that the I codes are updated on 3-year cycles. So there might be slight differences from jurisdiction to jurisdiction. So again, IBC in the state of Illinois is administered at the local level, and the same is true for the IRC, the International Residential Code. Again, in the state of Illinois, it's administered at the local level. So what does that look like? So in the, I happen to, as I say, live in the Village of Oak Park. So the Village of Oak Park has adopted all of these I codes for construction activities that take place in the village. How do I know that? Well, I went to the website for the Village of Oak Park. This slide might be a couple years out of date, right? Because I think I built this lecture a few years ago, but in essence, you see that they list the different I codes that they are following, and a lot of them say, right, here's first line, the first bullet, 2009 International Building Code, IBC, for existing buildings with local amendments. So with local amendment means that Oak Park is following the 2009 IBC, and they have other things specific to Oak Park that they have tacked on there. So again, if you're going to design or build an Oak Park, you'd want to be familiar with obviously the IBC, as well as the local amendments that might apply to the work that you're doing. Here's an example of a local amendment. Right, in this case, the local amendment is providing some climatic design criteria that get used: snow load, wind load, seismic, right? Seismic relates to earthquakes, frost line depth, right? That would be an example of that's probably the clearest example of what local adoption would look like. Because again, if we were in Arizona rather than Oak Park, obviously the climactic design criteria would be different, right? There's obviously we don't have to concern ourselves with a 42-inch frost line depth in Phoenix or Tucson. That's a wholly different set of considerations. So that's an example of some of the things that might be in a local amendment. A local amendment, certainly in Oak Park, I know there are historic districts in Oak Park. Those sorts of things would be covered in a local amendment as well. I said that most jurisdictions in the state of Illinois will be using the IBC or the IRC. The city of Chicago is an exception, right? The city of Chicago has its own, develop and implement its own building code. So if you are working or building in the city of Chicago, you wouldn't be following the IBC or the IRC, you'd be following the city of Chicago building code. So some of the larger cities like Chicago, New York, Boston, etc., they have their own building codes that they follow. But most other villages and towns and jurisdictions would be adopting one of the I codes. Some additional codes that might apply. This one, the ADA or the Americans with Disabilities Act, isn't really a building code. I don't know why my phone's ringing here. Sorry about that. The ADA is in essence a law that was passed that says that buildings need to make reasonable accommodations for people with physical disabilities. Things like door widths and door swings and lever hardware on door and the size of the toilet stalls, all these sorts of things, right? So these are all things that need to be followed in the design of a building as well. Some other codes that you might run into, depending on the nature of the work that you're doing. NFPA is a specialized code for life safety, for sprinklers, for fire protection, that sort of thing. Generally, it's going to be more related to industrial processes. So let's say if you're working in a factory building or in an industrial setting, you might have some things related to NFPA. Christoph, this is probably one that, and others of you that are in the electrical certificate program, the NEC or the National Electric Code is where essentially more detailed information comes from. I think a lot of the things in the IBC or the IRC are lifted from NFPA 70, but source of a lot of the underlying source of a lot of stuff related to electrical codes would be in NEC. So again, this is all going to be stuff like wire sizing and conduit sizing and conduit fill, right? How much ampacity can a piece of number 12 wire take? How many pieces of how much number 12 wire can you put into a piece of 3/4 inch conduit? All those sorts of things. Another, in this case, this is a standard, but another thing that you might run across would be this particular energy standard, ASHRAE 90.1. And when I flip presentations here, this is actually the basis for a lot of the things that are in the IECC, International Energy Conservation Code. Again, I'm going through this stuff. If you have any questions, if something doesn't make sense, please shout out or raise your hand or put something in the chat box. Let me change presentations here. Hold on. Sorry, Blackboard limits the size of materials that I can put up on that I can share on Blackboard here. So I had to take my presentation on energy codes and slice it and dice it into a couple slices to get it to fit. So anyways, the IECC, the International Energy Conservation Code, is based on ASHRAE 90.1. Again, this has to do with the construction. A lot of it has to do with the construction of the building envelope, how much insulation, what types of windows and doors, that sort of thing. Again, I have this same lecture that I give to my ARC 110 class, my sustainability class. We talk a lot about building code requirements for the construction of the envelope and how we need to do better than code minimums. Because again, building codes define minimum standards of construction, but certainly in the case of energy performance, I'm always encouraging students to do better than minimum, right? You want to have a better building, a higher quality job. If you're an electrician, you want to be better than minimum, right? You want to do a good project for your company and for your customer. So again, the IECC, defines things related to energy. You see the word shall. Again, building code language will typically say shall. You shall do this, you shall do that. In the case of the energy codes, the IECC divides the country up into these different climate zones and then applies different standards related to the building envelope differently by climate zone. So once again, this is from the IECC. You see the climate zone listed 1, 2, 3, 4, 5, 6. Climate zone 1 is Miami. Climate zone 7 and 8 is Duluth, Minnesota. So this is all fairly logical, right? The requirements for R values for insulation and ceilings increase as you move from a warmer to a colder climate zone. Ditto for the insulation requirements in a wood frame wall. Again, this is examples of things that would be in a building code, right? This would be things that either the designer would pick up and put in the design, or we'll see in a minute, we'll see what specifications are. This might be something that, a sentence or two that gets buried in the specifications someplace. Wall construction shall meet all requirements of the International Energy Conservation Code, right? And then it's incumbent upon you as a contractor to find that in the code and make sure that you understand those requirements. So along with a building code is a building permit. Again, each village or jurisdiction will have a slightly different process, but generally speaking, if you are going to go do something, if you're going to build something or make a major renovation, you typically need permission from your jurisdiction, from your town or city or your village. You need permission to do that work. That permission is called a building permit. So depending on the nature of the work that you're doing, you might have to submit a set of drawings and have them reviewed by the building department and a permit issued based on those drawings. Or if it's something fairly straightforward, you may be able to just walk in and pull a permit. Right? You'll see a picture of a permit from the window in my house, or my Francis in my house, right? I'll have to look and see what work it was, but we may have just had the contractor go to the village and pull the permit. So again, the jurisdiction, the Village of Oak Park, has a building code, and the permit process and the inspection process that goes along with it is essentially the enforcement mechanism, right? Just like the village has a speed limit, right? It has a speed limit of, say, 25 miles an hour. So the speed limit is the rule, and the enforcement mechanism is the cop at the corner with the radar gun. So in the case of how the building needs to get built, the rule or the law is the building code, and the enforcement mechanism is the building permit and the inspections that go along with the building permit. So again, this is all stuff that's done by local jurisdictions, by cities and towns and villages. Oops, sorry, this is coming out. I don't know why the little picture's coming out sideways. It looks correct on my preview screen and coming out sideways here. So I have to apologize for that. But in essence, the little piece of paper there, which you probably can't read very well, says permission to work. So for us to do work, we went, or our contractor went and pulled a building permit, and we posted that permit. And that means that in the eyes of the village, we are allowed to do the work that's described in the permit. So again, depending on the nature of the work, if it's a large project, then the general contractor might be required to, might be the one that pulls the permit, or individual trades might be required to pull the permit, right? Those sorts of things would be described in the specifications that we'll look at here in a few minutes. Again, we talked about the analogy of a speed limit, a law, and the enforcement of the law. So the enforcement of the codes takes place at the local level. There's two sets of code enforcement officials. The first would be the plan examiners. So again, if you are building a new building, you or the architect or somebody would take that set of plans to the Village of Oak Park, and you would submit the plans, and a plan examiner would review those plans and either approve them or maybe come back to you with questions or comments. And those plan examiners may actually take the work and break it up into, certain subspecialties, right? There might be a zoning review and a site review and a plumbing review and a mechanical review, right? Depending on the complexity of the building or the size of the plan of the building department, right? That plan examination would be done. But at some point, you would have a stamped set of plans that said you can build according to this set of plans. The other piece, and then from those approved set of plans would come a building permit or a permission to work. The other piece of enforcement is the inspector. So there will be building inspections done along with the building permit, again, depending on the nature of the work. Let's say you're building a house. My guess is the inspector is going to want to see your excavation before you pour the footings for the foundation. You might want to make an inspection of the piping that you're going to, the plumbing that is going to get buried underground. You're certainly going to inspect stuff before you close walls up. But again, you as a contractor would be generally familiar with what the inspectors in the jurisdiction that you're working in are going to want to see from you. And the other piece of enforcement, would be certification of contractors. Again, in most jurisdictions, you as a contractor will need to have a license to do business in that particular village, in that jurisdiction. Again, you might be probably required, if you're going to go and pull a permit, you probably have to show your contractor's license before they'll give you a permit, right? If you're a plumber or an electrician, right, they're going to want to see your license before they issue a building permit. So again, those are the ways that jurisdictions will enforce the building codes. So again, the process, you apply for the permit. There is a plan review, right? Plan review is the drawings are looked at it in at the village or at the town hall and the building department. That plan examiner is looking to make sure that your plans adhere to the building code that city or town follows. And again, once the permit or the permission to work is issued, there'll be inspections. And then again, depending on the nature of the work that's being done, the final step would be a certificate of occupancy. So again, if you're building a new building, certainly a commercial building, generally speaking, at the end of the process, the building again will be inspected. Probably this time you're going to have the fire marshal there, and make sure that all the things that are necessary to make that a safe building are there. And then they'll issue a certification of occupancy, which means that you as the owner can actually start using the building, or you as the general contractor can turn the building over to the owner and say, hey, I'm done, give me my final payment. Here's a link here. I think I had it on some of the other slides, but that's the link to the International Code Council. I will put this up. I'll post this on Blackboard. probably do that tomorrow, but this will be an assignment for next Tuesday. So this would involve doing a little bit of investigative work. Hopefully you can do this online and put these couple things in a simple PowerPoint and post it to Blackboard. So, you know, where do you live? Excuse me, what building codes does your town or village follow, right? I live in the city of River Grove. River Grove follows X, Y, and Z. Are there any local amendments? What type of work needs a permit? And what type of work does not require a permit? What's the process for applying for a permit? And how much does it cost? Alan, obviously you know where you live. My guess would be that my first step would be to go to the website for your town or city or village. They probably have a building department website that has information. Worst case, you might have to make a drive over to your city hall or your village hall, but and find that stuff out. But I would think you should be able to find this information online. Most towns and cities have this stuff up online now, or at least this level of information. You know, if you were actually going to do a project or build something and you had questions, you would probably go, I'll say go downtown, but go to the village hall and talk to somebody there. Hey, I have a question, et cetera, et cetera. But yeah, that would be my first step. Any other questions? Okay, again, I'm recording the lecture here, so I will post a recording of the lecture on Blackboard here. Hopefully I'll have some more time tomorrow evening and Saturday to catch up on my Triton work here. Let me switch gears and we're going to talk about one other thing. Yes, I think you might check it out. I think, Christoph, that a lot of the things that we're talking about are going to happen at the next level down from Cook County, but you certainly can look around. Okay. We're going to talk a little bit about specifications here for the next, I don't know, half an hour or so before we take a break. So this is material in chapter 6 of your textbook, if you happen to have your textbook handy. Yes, Charlie, yes, this is the book this is the textbook for this class. So you see it says 7th edition. So yes, this is the textbook for the class. Again, for tonight, since some of you are just joining and haven't had a chance to get your textbook, I've emailed you materials that you'll need for the activities, but a textbook is a requirement for the class. Jaquan, yes, I understand that. Yeah, I figured that some of you didn't, and that's why I did things the way I did today. So hopefully we'll be able to get one in hand here in the next few days. I know sometime, I don't know, I always see the Amazon Prime truck driving around, so stuff seems to, if you want it, it seems to come quickly these days. So we're in Unit 6 or Chapter 6. We've just talked a lot about building codes. We talked about zoning on Tuesday. Now we're going to talk about specifications. So what am I going to try to get done? Explain what's in a specification and why they are needed. Get some understanding about what's in the specification. We've already talked about how building code requirements impact the building process. So that's what we're going to try to do here. So what is a specification? A specification is a written document or a written statement that defines the nature of the work, that defines the work that has to be done. Those written documents define the quality. They'll define materials that can and should be used, workmanship. Specifications are often called specs, right? This class is code, specs, and print reading. And the specifications supplement the drawings. So drawings and specifications taken together constitute the construction documents. And those construction documents would be the basis of any sort of legal agreement, any sort of contract between the owner and the general contractor to build the project. They would be the basis of a subcontract between the general contractor and the mechanical contractor for that mechanical contractor's portion of the work. So again, we are more familiar, or you guys may be more familiar with drawings, but again, for a construction project, contract documents typically consist of drawings and specifications taken together. So why do we have specifications in the construction business? Well, the owner, the person who's putting up the money for the project, the person who wants to have use of the new building that we all are going to build for them. We all in the construction business, be us architects or electricians or plumbers or carpenters or contractors, right? We all have a different role to play, but we are all working together to provide a project for the owner. So the owner wants to describe and define the quality of the work that they expect. So the architects in the specification is going to define the materials and the processes and procedures and the quality that they expect to have in the project. Again, the engineers, the electrical engineer, the mechanical, the structural engineer, again, they're going to typically define the standards that will be followed, and the specifications will often have supplemental information that's not contained on the drawings. And contractors, they're going to use the specifications to understand the intent of the work and to be able to make a bid to the owner or whoever they're bidding to that shows that they understand exactly what needs to be built. And once they build the building or in the process of building the building, again, the specifications will describe in detail what it is that they have to do. Generally speaking, the construction documents describe the what. They tell the contractor what they have to do, what you're going to build, what materials to use, etc., etc. Generally speaking, it's up to the contractor to figure out how to build. The specifications and the drawings generally don't say how. They generally don't specify what's called means and methods. It's up to the contractor to determine means and methods. So the architect will be very clear that I'm not going to tell you, I'm going to tell you what to do, but I'm not going to tell you how to do it. Right? It's up to the electrician to know how to bend the conduit to make it fit in the certain space. It's up to the plumber to know how to sweat the pipe. It's up to the carpenter to know how to nail the wood together, etc., etc. So again, these construction documents will be the what, and it's up to the contractors to figure out how it gets done. Means and methods is up to the contractors. Right, the contract specifications will also outline certain non-technical aspects of the project. Typically, the specifications will talk about things like how much insurance, what are the insurance requirements for the contractors on the job, you know, who pulls permits, how those, you know, whose responsibility will be for permits, whose responsibility will be for permit inspections, you know, what level of supervision is required. Right, and you see on the slide there some examples of the types of things that might be included in a specification, right? All footings shall be carried to undisturbed medium sand or rock and to at least the depth shown on the drawings. Right, here's compressive strength of concrete. Right, so again, the drawing would show the depth of the footing and the dimensions of the footing, and the specification talks about the compressive strength of the concrete and the types of aggregates to be used, right? So again, the construction documents are both written specifications and information contained on the drawings. Specifications are divided into divisions. Right? Divisions are following a system laid out by the CSI, or the Construction Specification Institute. They've divided construction up into 50 divisions, or at least they have space for 50 divisions. Not all those divisions are used at the present time. Right, but here are examples of the divisions in the CSI format. So you see the different aspects of construction are put into different divisions. Just think of this like the chapters in a book or chapters in a textbook. Right, if you're Christoph or whoever, Charlie, one of you was the electrician. Yes, specifications, Nicole. Yes, specifications will reflect the building code. That will be hopefully the person writing the specification understands the code, but there will probably, in all likelihood, there'll be language in the specification that says, in addition to all the other things that it says, there'll be a sentence or two in that says all work shall conform to the latest revision of the International Building Code, or all work shall conform to applicable building codes, right? There'll be general language like that in there that puts the onus or the responsibility on the contractor to understand the code and to follow the code. But yes, specifications should follow the building code, right? Building codes are still the rules that we're all following. The building code is the speed limit, right? 30 miles an hour on Madison Street. That's the law. So again, you see all the different divisions in the CSI format. So again, within those divisions, they're further divided up and organized in ways that it helps people to find the information. Right, the specifications for a large building project could run into the many hundreds of pages. So the specifications are organized in a way that allows people to find the information that they are looking for, right? For the contractor to make an estimate, to bid the work, to know what it is that they are bidding on and what it is that they have to do to construct the building. So within each one of those divisions, right, in division 26, which I think was electrical, you'll typically see these sections. So typical sections heading in a specification. Related documents will say, refer to this part of the drawing packet. It may also say you have other things in this other spec section. Talks about things like pay applications, insurance requirements, a summary, a quick description of what's in the specification. Related sections, again, it may refer to something that's in another division. Definitions. So there's a quick comment, a understanding of what certain words mean. References. This would be, depending on what division you're in, right? If we're in division 26, if we're in electrical, the reference might be to NEC, right? It might say, follow this particular standard from the underlying NEC or whatever, or have standards for any number of things, right? Standards for the paint, the finish, the door handles, right? A lot of trade organizations, right? The trade organization for paints and coatings may have a standard, and the specification will say all paints and coatings shall adhere to the requirements of the American Paint Society standard number 6257, right? Description of the work, quality assurance, It may say something like, all electricians shall have this particular certification. It may say you have to provide a mock-up or something to be approved, right? Certainly if you're doing finish work, you might have samples and mock-ups that have to be done and be approved by the architect. Quite often in a specification, there will be submittals. Again, if you're in Division 26, so you're the electrical contractor, right? You typically will go to your equipment supplier and get a submittal for the switchgear and the panel board and all the different products that are going into the project. And typically you will submit to the engineer of record, and that engineer will approve your submittal or take exception to your submittal, right? They'll say, okay, the panel board that you've submitted meets the intent of the specification. So based on the approved submittal, you'll go out and order your material. There might be special inspections, pressure testing of piping, pressure testing of ductwork. If you're the person pouring the foundation, right? You probably have to save a sample of your concrete that's subject to testing to make sure that your concrete that you actually use meets the compressive strength requirements in the specification. Those are all things that would be contained or might be contained in the specifications. Specs will typically say what products are acceptable for this work. Quite often the architect or the engineer will have a basis of design. They may say something like, panel boards shall be as manufactured by square D or equal, or the specification might say something like, panel boards shall be as manufactured by square D or approved equal, right? Or equal means that you can submit on somebody else besides square D. If you're the electrician, you may be able to buy Siemens hardware better than you can buy square D hardware, so you're going to submit on Siemens because you can get that a little cheaper than square D. Or equal means that you should be able to submit on Siemens and get it approved. If the spec says or approved equal, then, and you're trying to get Siemens gear approved, you would certainly have to have approval by the engineer of record before they get to do that. Right, execution, again, a written description of what the work is. Again, the specification will say what, it doesn't say how. How, means and methods is up to the contractor. Right, protection might be who's responsible for protecting work in progress. Maintenance, right? Again, depending on what your division you're in. Again, if you're in Division 26, the electrical contractor, part of the specifications will say at the end of the job, you're going to submit all the operations and maintenance manuals to the owner or the owner's representative. You might have training requirements in there. You might have startup, right? If you have a piece of switchgear, it probably has some testing and startup that's required. Specifications may talk about warranty. right? Are you as the electrical contractor required to provide a warranty, right? You certainly bring forward the warranty from the equipment supplier. Are you required to provide a warranty over and above what the equipment supplier gave you? What responsibility do you have for any repairs and maintenance? How is the work accepted, right? What do you have to provide to get your work accepted and get paid? These are all things that would be contained in the specifications. So again, there's a lot of stuff in the specifications over and above what are on the drawings. So really it's incumbent upon, depending on your role in the construction process, if you're an architect or an engineer who are writing the specifications, right? You're using the specifications as a tool to make sure that the final product reflects the design intent. If you're the contractor, you need to understand what's in those specifications because that describes what it is that you are expected to do. And there's lots of little ways that contractors can get tripped up if they miss something in the specifications. Oh, geez, I didn't know I needed to do that, right? I didn't know that I needed to test my high voltage cabling and have the testing approved before I can put piece of equipment X online, right? Okay, any questions? Nicole, did I answer your question?
Yes, I thank you for that. I was about to ask another question, but it's safe to say that you can't just rely on the specifications to make sure that you meet the code, correct? Because it corresponds to the code, but may not be super detailed.
Yeah, again, you as the, I mean, there's a lot of responsibility that's ultimately placed. Well, a lot of responsibility on everybody in a construction project, but let's say you as the contractor, it will be your responsibility to understand what's in the drawings, to understand what's in the specifications, and if the specs refer to a specific building code, for you to understand and be familiar with all those things, so you do your work in conformance with the contract documents, right? That's the, getting the lawyers involved is a thing that all parties want to avoid, right? So.
Right. So the specification is not a replacement for understanding the building code, basically, is what I'm understanding based on what you said.
Yes, that is correct. You really need to understand and be conversant in both the specifications and the code. I mean, the good news is that the building code is the same document, right? So if you're a electrician or electrical contractor, you're going to be familiar with NEC, and you're going to be familiar with those pieces of NEC that are in the IBC or the IRC. So, from project to project, those underlying code requirements don't change. So you don't have to, you're not going to be changing building codes. It's generally speaking always going to be the same code that you're following.
Thank you.
Well, you're very welcome. Yeah, certainly don't be shy about asking questions. As far as I'm concerned, the only bad question is the one that doesn't get asked. So if something doesn't make sense, please ask a question. I appreciate your questions. It gives me feedback on how clearly I am presenting the material and makes me think as well. So, okay, why don't we take, it's a couple minutes before the hour. Why don't we take about a 10-minute break so we will get back together Yes, Anna, the first class was recorded as well. So I have not gotten it up on Blackboard, but I will do that over the weekend. Yeah, I will be recording these lectures and posting them on Blackboard.